Association might take you 3 seconds, where running aircrack can run an indefinite amount of time, depending on how many ARP packets and traffic and those types of things. So we don't want to schedule those in the same run. We want to go through all the short ones first, then all the medium ones, and then all the long ones. And then there's run levels. That's basically just the order that they'll run in. So for example, you want to run, again, association first before you run aircrack, something. So this is the workflow. There's a whole lot of text on this page. I'm not going to read it all back to you, but I just wanted to give you a good idea of how it escalates through these. What this basically covers is how it escalates from one event level to the next. When it gets to a point where it can't go any further, it will schedule all the different access points before it goes to a longer run length of plugin. For example, again, take the IW config versus aircrack example. You don't want to waste all your time on one access point with aircrack when you can be looking at all the other access points first. So you want to make sure and run that, look through all the access points, then go back to those if needed. So then there's actually a plugin replay path, which when you move from a short to a medium run length, it will replay all the plugins that it took to get to this point. So when you want to go back and run a different plugin at that, you replay the association to get your IP, to get on the network to try to do things. So then you just repeat that until you get to the end, which is either the highest event level, and then you run through all the plugins in that event level, or you get stuck at any given place. You just can't get through an access point, something like that. Different types of plugins. I already talked about this, but basically you can schedule plugins so that you can have things like all your access point based plugins, things that are actually checking something on an access point. They'll be scheduled, but whereas a hook, you want that to run immediately after those things happen. For example, moving an antenna. You want to start moving the antenna before discovery. When you do discovery, when you find an access point, you immediately want to record where your antenna is and where you are. And you want to have that you want that to happen immediately. You don't want it to schedule it in the future, otherwise that information is bad. And then you want to announce it, those types of things. So those are the different types of plugins. Plugin interface just talks about how the plugins talk to the plugin engine. You spawn it, you send in arguments, you put in things to the environment. It comes back in one of three ways. Either standard out will give the reporting, human readable type information. The return code tells what it's supposed to, the exit status, so it, whether you're successful at increasing the event level or not. And then it can also talk directly to if you have programmatic data, like say the GPS coordinates, you can send that directly to the plugin engine. Here's some plugin examples. I talked about a lot of these. Associate. It'll check to see if you can get to the internet, how fast, what your latency is. Run Nmap, aircrack. Run Nessus. We have a couple plugins for WebLab and Cowpatty to try to brute force in. It'll randomize your MAC address. Again, GPS, text-to-speech. And in the future, again, the power is in the plugins here. So as many plugins as there are, that's how powerful it's going to be. And so we want to continue to add all these different plugins. So the first few are like trying to defeat captive proxies, check for rogue access points. There actually is a plugin for checking for rogue access points. It tries to just check to see if it can get back to a known server and get some known text. If it does, then it announces that. And then there's all the other obvious security tools for pen testing and things. Just a subsection of the other architecture document, a bunch of boxes. This slide is up here really just to show you how easy it is to write a plugin config. You just tell it, I don't know if you can read this, maybe. Just tell it the name, the binary you want to run, some other things about where you want it to run. Again, the run length, event level, those kinds of things. The profiles. this is what tells the plugin engine how and where and when to run. It's the things it manages. For example, again, it manages the cards. So the card scheduling types there are first all traffic and signal. First is just start running plugins as soon as I find an access point. All is I want to try to make sure that I can get all the access points I can find with some reasonable certainty that there aren't any more based on some timeout value, and then start running my checks. Traffic just means that you're going to start running plugins on these things in order of how much traffic is on there. So if you are trying to run webcraft, you're more likely to succeed. Signal is same thing for signal. Profiles also determine what run length. So I'll give you some examples here in a second. Profile examples. The different users or use cases are going to select how they want Wicrawl to run through the profile. So they're going to have different settings for all of these things. A pen tester is going to schedule the all card scheduling, which means, again, you want to look through all the access points that you filter on. Schedule all the plugins, run all the run lengths, those types of things. Or driving, you're going to be, moving around in a car, whatever whatever, and so you want to only run the fast ones, the first card scheduling, so look right away. Only the basic plugins, if any plugins at all. Maybe you just want to do discovery. Holding internet access, you probably want to schedule based on signal because you're a little bit more likely to get a good connection through that. Probably only the basic plugins and probably short run lengths. Our UI, I think, is I think it's pretty sexy for a wireless tool. It allows you to configure the plugins and profiles through it. It's themable, so you can run it at night and wherever you're scanning for access points in the night. And it reads all its information from XML files for the different plugins and the access points. So it's easy to replace this UI with, say, a text UI, which we're actually looking for. If anybody wants to help us out with the text UI, that would be pretty cool. It also has a war driving roll-up status bar, so that the thought for this is in California, there's a law that any mounted display in your car can only have car data displayed on it, or related to those things. And so you don't want to have just your access points are probably not related to how your car is running. So if you just have a status bar that can tell you how you're doing, that kind of thing. I talked about this. The UI just forks the plugin engine, reads the log file to get sort of what it's doing, but all the actual data is read directly from XML files, so that it's sort of hopefully a pluggable component, so we can have multiple UIs. Here is the UI. You can see a few things right away, where we have a few different access points here. They're colored in order of their event level. So the event level for have internet is green, because that's a good, versus we just have the access point is red, and then yellow for somewhere in the middle. Here's the plugin output, so you can see it's drilled down to the given access point, the run that we've done, and then the output for the plugin. This happens to show the association plugin. It was not successful there. Here's the status bar. Again, just kind of a roll-up bar. You can see sort of the ratios of how successful we were, and a easy to read color bar graph there, and also the ratio of encrypted to none. Here's the nighttime theme, similar. Nighttime status bar. So here's the status of this. We're going to have a beta release here. It's the first real release of this. Linux only for now. Probably the next easy targets, I guess, for us are BSD and Mac. I don't know when, we're busy working on, the main part of things, so we'll get to that next, I think. There are a few bugs right now. We need to clean up some of the plugins, but it's pretty usable. We'll give a demo here in a minute.
Okay.
The card support needs to be validated here. You know, there's just so many different drivers and so many different cards. It's hard to know what you really support until you test all those plugins. Again, the power's in the plugins. We need, you know, we'd like to develop some more plugins to do some more checks. The UI's done, but like a text UI, I mentioned that. In the future, we have a few things we'd like to be able to do with it. First of all, be able to do multiple computers so that we can maybe cover a whole campus at once in a pen test example, or you know, basically be able to have a cluster of systems together that are all connected and doing intelligent scanning. Multiplexing the access points, that's kind of a 2.0 thing that we'd like to basically be able to associate to multiple access points through the same card, so you can, you know, again, sort of multiplex those things. So you have your, you know, software stack of you know, your 8 to 211 stack, so you can do this. Plugins. Also, our info registry, so plugins can send non-related programmatic data back to the plugin engine. Card capabilities. One of the things I found writing this stuff is that there are a lot of different cards who have a lot of different pieces of functionality. For example, you know, the obvious case are some cards can monitor, some, you know, can't, or some drivers, I guess. And there are different things. For example, you know, sometimes you can inject through the same interface. You know, this is getting even more complicated with the new Mad Wi-Fi drivers, which actually allow you to have a monitor interface and a station interface at the same time. So you can actually run, this is kind of cool, you can run discovery, continuous discovery through a single card, while at the same time using, again, a virtual AP to run plugins against those access points that you're finding. It's still a little buggy, but it's a cool concept to be able to do that. But obviously not all cards can do that, and so we have to keep track of all those little things, because certain plugins will require certain features. We want to be able to do better reporting, so, you know, like in the pen test example, we can have something that looks a little better. Ultra Mega AP scanning behemoth, Wi-Fi distributed cracking flash mob. I don't know. Those are things that I think would be pretty easy to do with Wicrawl, because we can. I mean, we've stuck probably, I don't know, 6 or 8 different cards in just a laptop and running scanning on that. So you can run, again, you have plugins that run in parallel on all of these things, and then just have that sit on top of a cluster that allows you to do either scheduled cracking or other types of distributed cracking against these types of things. It wouldn't be that hard to do on this, plus you know, some other tools for you know, HPC type. You know, there's a bunch of different distributed crackers now. Pretty important slide. I thought about maybe putting this at the front of the talk, but the elephant in the room here is there's a lot of liability for scanning and running these kinds of tools. There's a lot of different use cases here, and you have to be really careful about these days about what you're connecting to, especially if you're doing, you know, active active attacks. You know, people draw the lines in different places, and there's some sticky cases